Hello, everyone, and welcome to another K6 Office Hours. I am Nicole van der Hoeven, as usual, and today I have two people with me. One of them you may remember from a previous K6 Office Hours, and that's Pawel Suwala. Pawel, who are you? Why are you even here?
Yeah, that's a good question. Why am I here? Since we have Samuel. Samuel should be doing all of the talking, right? I don't know. I guess I will help and answer some questions that will come up. But who I am, I'm still the CTO of K6, and I'm still doing many different things: project management, planning, organizational stuff. I do some coding from time to time when I get some time. Yeah, meeting customers, doing some all kinds of things. Whatever shows up during the week, I'm the one that is picking up things that don't have clear responsibilities for others, I guess.
And welcome to the stream, Samuel Regandell. Am I pronouncing that right? Probably should have
It's
confirmed with you beforehand.
it's a Swedish thing, so Regandell is actually
Regandell.
yeah, so it's actually the emphasis on the second one. Yeah, so hello, I'm Samuel. I'm Swedish, and I'm sitting here in Uppsala, north of Stockholm. I'm the one of the team leads for the backend, and yeah, so that's basically it. I've been at the company for 5 years now, and has seen a lot of changes, of course, over time here. So
5 years. Wow. How long have you been here, Pawel?
I think in couple of months it will be 4 years for me, and I feel like Samuel has been here for longer than 5 years, probably. No?
no, yeah, maybe I don't think no, I think it's 5 actually. I used to walk around and tell people that it had been at least 5 years, like a year ago, and then I actually counted, and I realized that's actually over exaggerating the whole thing. So
that's
yeah,
probably why.
Yeah. So I was myself confused by this.
So I'm the newest one here. I've only been at K6 for a year and 3 months or so. But I'm glad to have you both here. Samuel, why don't you tell us what you do for K6 on a daily basis?
Yeah, so I'm leading one of the two teams of backend development, which actually pretty recent development. We used to be only one team, which I led, but we are now split into two because we're getting to be more people. So I do the whole people management aspects of the team, but also the day-to-day operations of planning. We plan for projects. I also do a lot of development myself as well, so a lot of back-end work and planning going into it, and day-to-day operations.
What is your favorite part of the job?
For me, I think the favorite part of the job is the creativity of it. I've always seen coding as a creative endeavor, and I do a lot of other sort of creative projects and stuff in my free time. So development and programming is just one other aspect of that. I think the ability to. I mean, coding is a sort of a mixture of creative and technology, right? And you have to follow certain practices, etc. But it's not that different from any sort of art form, in the sense that you need to be good at the technology. You need to have the technical skills to do it. But there is still, I feel, room for expression and room for design, your own design and your own thinking in it. And I think this is a good thing and something I really appreciate about it. And then, of course, I'm also a manager. So I'm also have a chance to talk to people and getting to know people and handle that aspect of it. So the social aspect of it is, of course, also useful, especially in these days when everyone is working from home, right? And as you see, I'm also working from home.
Samuel has another secret job on the K6 team. He is the organizer of the monthly K6 board game night.
That is true. That is true. But I mean, I have a set of board games behind me here, but I should tell the audience that I cannot beat Nicole's list.
We play virtually anyway. Honestly, I haven't played many of my physical board games in a while.
No.
But Pawel, was it your decision to separate the one backend team into two, and why was that decision made?
So I wouldn't say it was my decision, because the decisions that we make in K6 are always around consensus, and I cannot make decisions like that on my own and dictate how the team will be organized. So it's always a discussion of how do we organize ourselves when we grow, and we seek input from many team members and reach consensus, and then we decide something. So I cannot really take responsibility for this decision, but I can tell you why we decided to do it. As you know, and as all of us know, we are growing quite quickly, and we are hiring more and more people. And at the moment, I think in the backend, the purely backend engineers, I think we have 11, and we are planning
11.
to have 14 in a short order. So having 14 people in one group is a little too many. So primary reason is that we wouldn't be very efficient, and we decided to split it for that reason. But there are many reasons, right? So Samuel can pitch in here.
It's also, yeah, so there are also the practical reasons of having, I mean, I try to talk to everyone every week, to have at least a half an hour to an hour meeting with everyone face to face, or at least camera to camera, and just practically having 10 other people to talk to in a week would probably, I would only do this. So from that perspective, if I'm also wanting to do any coding work or any other work, that would not work. I think it would also be tough to keep up quality, personally, at least for me, to do that if I'm just going from meeting to meeting and try to keep up with everything. So splitting it is just also a practical matter for and having, as Pawel mentioned, having a smaller group. Even if you have a meeting within the smaller team, it's much easier to be able to actually go more deeper into problems people have, even if you discuss in a smaller group, than having all 11 people all trying to speak. Then you can't just fit that in an hour. That takes much too long. So yeah, but we also try to also have every week a sort of group meet between all the members of the backend, so both teams, so all 11 people, where we just in order to keep a social relationship between each other and keep a cohesion between the backenders, because we also don't want to have that one team is the isolated thing from the other one, because I mean we're all working on the same code and we're all collaborating on things. So
Yeah, that totally makes sense. I did post a link in the chat to the positions that we're looking for right now. It looks like we only have one up there at this moment, but Pawel, you already alluded to the fact that we are still looking for many positions, or we will be soon, and some of them are going to be on the backend team, or one of the two backend teams, right?
I think on both of the backend teams we'll have openings quite soon, I would say in 2-3 months. We are at the moment not having those openings because we have hired quite many new people, and we don't want to go too fast to just create chaos. We have how many new engineers are we onboarding right now, Samuel?
2, 3, I think. Well, depends on how you mean onboarding. We have 4 people started basically this year. So they are in different stages of onboarding. I think 5 total since last October or last November maybe. Mm-hmm. And so we feel we don't want to grow that too fast in that regard. You have to allow people to acclimatize to the environment, and also to get them going and helping them out and so on. So yeah, we feel that we don't want to expand faster than we are able to properly absorb the newcomers.
But I think that we will open those positions around May, maybe this year, something like that. So if anyone is interested, keep an eye open on open positions and apply.
Yeah.
Yeah,
Definitely.
so 11 people and 3 more positions soon in the next few months. Why do we need such a big back-end team? What are some unique issues that we might have for K6 and K6 Cloud, really?
So yeah, so the backend of what I call the backend here, that's the K6 Cloud offering, right? So it has several responsibilities apart from the SaaS service basics, like you being able to set up the organization, get subscriptions, etc. All this meta stuff. What we also do is to ingest the data from either from your locally running K6 or from you telling us to run K6 for you in the cloud. And this is stuff that is we absorb a lot of data over time, and we have a big system that requires, of course, and we're also trying to gradually upgrade this and update it to other standards, etc. I mean, we have created this system back in a time when to some extent many standards around metrics were not really available yet. So internally we are shifting to this status, but even existing tooling doesn't quite do what we need yet, and that's not quite catching up to what we can do in the cloud. But this takes a lot of resources, human resources, of course, to be able to not only upgrade our current system, but also to maintain what we have, because we are growing and we are getting more and more people using the system, which means more and more metrics going through it, and more tests running in parallel. And there are so the optimization and the improvement in performance of this is an ongoing thing that we need to be careful about. I mean, Pawel remembers how the limits we had on the system only a few years back, and how it has improved dramatically since then. But yeah, so there's a lot of things to do, of course, still here. So.
Yeah, and I would add to this that we are getting more and more customers, and not only that, but I think customers are building more complex tests that have many custom metrics, many modules, using extensions, using JavaScript libraries, and all of that needs to work flawlessly in the cloud, because customers are using us in the CI environments. So if K6 Cloud test fails, it creates disruption in the entire pipeline or build pipeline for the customer. So we are trying to be as reliable as possible, and it doesn't happen on its own. So there is a large engineering effort to make the system reliable, because of course K6 customers and K6 users can write arbitrary JavaScript, and that JavaScript can do almost anything, and it needs to run well on our servers. So that there is always work to be done with all of the inventive scripts that customers are writing.
Yeah, and actually I think that there are a lot of reasons, right, to use K6 Cloud. And some of them are, the ease of use and the nice interface, having that as an easy way to walk people who maybe have never started a load test before into the whole world of load testing. But personally, the thing that I would find the most value out of a load testing as a service kind of platform like K6 Cloud is the fact that it handles all the results for me. Because I always think it's such a shame that we have a tendency to focus a lot on the scripting of a load test, when actually a lot of the value that you would get from running a load test or performance testing in general is in the results. And the load tests just generate so much data, right? This is part of the reason why it made sense for Grafana to acquire us. But having had nothing, and having to figure out how to, aggregate, well, first collate the data from several load generators and making sense of it and aggregating somehow, because you can't, it's very difficult to maintain all of the raw data for all time. That's one of the selling points of K6 Cloud, that all of this is just handled for us, right? You don't even have to worry about how it's done. And it's the backend team that is primarily responsible for that part of it.
Yeah, as you say, the aggregation of data from a huge number potentially of separate load generators all coming in. All these time series need to be aggregated in a way that makes sense, because you not only have a large amount of data, you also have a large amount of ranges of values. So you have the a rate coming in, cases measuring some rate from, or request rate, response time. That could value from some few milliseconds up to several seconds or even longer. That's several orders of magnitude of scale. So averaging over that, for example, would not work. That would just be adding a small number to a big number kind of thing, right? So you would end up in problems with that. So yeah, so a lot of it's a lot of complexity to be able to handle this data in real time. Well, as close to real time as we can get it. Of course, there are always improvements we can do here, but yeah, because the user wants the result as quickly as possible, obviously.
Yeah.
So can you walk us through what actually happens when, for example, I start a load test on K6 Cloud, let's just say one generator, a handful of users. What metrics do we capture from that? Is it everything from the built-in K6 metrics plus custom metrics? Is it raw? Do we process them on the fly and only save the aggregated values? How does it work?
So what happens is that you have, say, we example of one load generator. Your K6 itself is first aggregating a bit, and then so it's doing because it had, so each load generator is aggregating and sending batches of data to the cloud. I think every 6 seconds of data. We receive that. And it's actually going via, regardless if you're running cloud or if you're running, K6 -- out, and just push the data to us, we are using the same input. It's just that, you are running K6 yourself or we are running it in the cloud. The data comes in, we unpack it and deal with it serialize it in some ways, and then we are going to queue it up for storage into the database. And this database is a custom, it's basically a Postgres database that we use with a custom extension called Timescale that is optimized for time series data storage. And so the data, but we don't put the individual data from K6 into the database. Because I mean, it for one single load generator, that may be actually reasonable, okay to do potentially, but for a big test, when it could be a large number of load generators all dumping data into the same pipeline then you're going to be having, within every time slot, you're going to be having a lot of values for every metric for that particular time slot. And as I said before, they're all going to be spread over a large range of values potentially, because of the way networks work, and can have it's a very noisy data. So we do something called dynamic range. Apply something called a dynamic range algorithm on this, where we basically distribute the data across a sort of logarithmic scale. It is a logarithmic 2-base scale, where and this is what we then store into the into the database. An advantage of this approach is that we can be sure of the error we have here. Because if you just were to take the plain average or some sort of weighted average maybe over each time slot, you don't know if you're throwing away spikes in the data, because the average will smooth it out. And more importantly, you wouldn't know the error, the maximum error you would be getting. But when you do something like a dynamic range or divided into buckets, basically, you know how many buckets you're placing. So you have a way of telling, we have so many buckets, so we won't have a worse error than 1%, for example. And that also means that the data and it also cuts down dramatically on the amount of data that you are storing, because it no longer matters how much data is actually coming in, because you're aggregating it into these buckets. You're going to have this amount of buckets, but they're going to be a different amount of content in each bucket. So storage-wise, it helped us a lot, and I'm saying this because we used to store all the data in the database as they come in, and it just ate up the database very, very quickly as we grew more popular. Plus, we didn't know what the error was, so we would have, you could potentially have like 50% off from the real values when you compare it to what we store and the averages, etc. So so at that point we store this into the database. This is all custom written routines today, and then we do, once we have that in the database, then we are going to run other processes on it, like pre-calculating the 95th percentile or all sorts of different useful things that the user will need. But it's all operating on these buckets or on these dynamic range structures. And then of course we do apply in various ways the thresholds that are involved. We also do smart analysis, what we call it, where we actually analyze the result and try to figure out, give some reasonable advice. What the heck are you seeing in this data, which is also another thing that adds value, of course, to the customer. So this is all done at various stages of the test run. Partly, threshold needs to be done on the fly as it happens, as much as possible anyway. And things like analysis, of course, is done generally on the whole data set, so you can get a feeling for it. This is actually one of the things that may be. So the fact that there are actually batches of data coming in and being operated on in a time, if users ever notice that it takes a little while before a threshold is actually being respected even though they visually can see the threshold being crossed, that's because of this, because it takes a little while just to process things and have it go through the whole system. So even though you have, you can visually see something happening, it still takes a while before the whole threshold processor is actually finished working on it and realizes that, okay, we are across the threshold, time to stop the test, or whatever you wanted to do.
I didn't even know until now that we didn't take the average, we take the dynamic range, which is really so much better. Because that is a problem. I know Samuel and Pawel, you know this, but just to explain for others who may not, if you have maybe 10 values, 10 data points, and 9 of them return a response time of 1 second, but then the 10th returns 10 seconds, you would have in the average of those would be 1.9 seconds. And you might think, oh, it's less than 2 seconds. That's okay. No, the 10 seconds is a problem. If you just take the average, you're smoothing it out, which is what Samuel was saying. You're missing that valuable information on the spike, because maybe that's not a problem for the load that you're running at now, but maybe this is something that you'll see more when you're running thousands of users, or maybe you'll just see it in production and wish you had been able to see that in your test results. So I think it's fascinating that we're not taking averages. That's really awesome.
It's also a computational thing, which, as I mentioned, because you have such a wide range of values, multiple orders of magnitude, as I said, from like milliseconds all the way to multiple seconds. So at that point, yeah, just numerically adding the computers doesn't like to add a really small number to a really big one. So yeah, you're going to be losing precision just just by doing that simply.
So right now on K6 Cloud, when someone runs it on K6 Cloud, so not using the -- out cloud, but actually running it on K6 Cloud, where does that actually run?
So it runs on in Amazon. So we are running our own system is running in one of the load zones of Amazon, or one of the centers of Amazon. But as you know, you can specify in your script that which load zone you want to use, like somewhere in the US, so you want to spread it out depending on what kind of traffic you're wanting to emulate. So our controlling software, so to speak, is running in one computing center, but that in turn we also spin up instances running the K6 agents, which we call them, K6 instances, all around the world in the Amazon network on cloud.
So Pawel, what are some of the concerns for the backend for the next few cycles? I know you have something specific in mind for that as well.
Yeah. So we have been growing so fast, and we have those customers that are running very complex tests. So we decided that in the next cycle, and we work in cycles of 8 weeks, in the next cycle we will focus only on reliability in K6 Cloud. So we'll not be adding any new features at all. We'll just be working on making sure that the system is stable. The observability of our components is top-notch. We'll be making sure that our deployments are not disruptive to customers. We'll be setting internal processes within the company on how to deal with outages and disruptions. So incident management processes. We'll also establish a more detailed process for handling level 3 support. So a support that our CS colleagues cannot do themselves, but they land on developers' desk. And many processes of just making K6 more reliable, maybe respond quicker to customers, maybe evaluate thresholds a little quicker than at the moment. Yeah, that's the reliability is the theme of the next cycle.
Yeah, and that of course is that is of course falling a lot on the backend side, because everything is connected to the backend one way or another.
Absolutely. And I would say that it's easy to think that when you run K6 Cloud test.js, it is such a simple thing. But really, the complexity of executing a test in the cloud is massive. So you can just execute one command as a customer or a user, but in the backend, we might be spinning up 100 servers to handle that traffic, to generate it and handle it and store it and process it. So it's immensely complex system, but it looks also super simple from the user perspective, exactly as we designed it, right?
That is the whole point, yeah.
Yeah, I mean, I think that's how Samuel and the rest of the team are doing their job really well, because it seems so easy, but it's definitely more complex underneath that. But we've talked about metrics, but we haven't talked about the actual instances that are being spun up. How do you decide if I run 100 users versus 10,000 users? How do you know how many instances of K6 you need to spin up, or how many instances of the AWS machines you need to provision? How does that all work?
Yeah, this is a complex problem, and we actually run a special service, which is actually derived directly from the configuration, partly at least directly derived from the configuration code of K6 itself, just to be compatible, at some point we actually had our own validation mechanisms, etc., in Python in the backend. But yeah, it's better to be compatible and make sure that it's always up to speed with what you use on the CLI or on your own. And what we do is that, yeah, we have algorithms to calculate and figure out, based on the lodestone distribution you choose. We produce a mapping pretty much where we say, okay, we're going to need, and we're going to be this number of instances for this lodestone, for example. And I should say it's also possibility for individual customers in some way, if they talk to us, to tweak this a little bit, how many instances should be run on one, how many K6 instances should run on one server, for example. Because this matters, of course. We have an average, but we have depending on the type of test you run, this can you may need more memory or stuff like that.
Yeah.
But on average, anyway, this is what happens. And then we have a mixture of trying to reuse existing instances where possible. So we try to be clever about it. If we have already a bunch of instances just idling in a given lodestone, we reuse those. Otherwise, we spin up new ones and basically sit and wait until they have properly responded. And then we have, I don't know if I should, so basically what happens is that K6 has a little web server on it. It has an API you can call. So in principle, when you run K6, you can tell it like, now move up to use 10 virtual users, and now you can use 20. And what we have is a custom little program called a K6 agent that is mimicking you, the user. Because each K6, say you have 20 instances spun up all across the world, and all of them should represent a load test of, say, 100,000 virtual users or something. And each individual K6 doesn't know anything about the other ones. They're all running in parallel. And so the K6 instance are just told, or the K6 agent, I should say, is just told to tell K6 to up the number according to this plan, which we have split across all of the instances. And then you have, and as that happens, together they all, create the test run that you asked for. So that's sort of the basic underpinning. But it is quite important, I think, to note that we are using exactly the normal K6 in the cloud, like the same open source tool that everyone has access to. We don't have a secret source, or closed version or separate branch one. We may use the bleeding edge, of course, but that is the same bleeding edge which will be available to everyone. So there's nothing proprietary about the K6 that is run at all.
You mean we don't save the super secret special features for the paid version? What?
No, it's using the same K6, but it's we might be a little bit faster maybe to get it or to make use of it maybe, but not that much faster.
So Pawel, tell me what the motivation was for adding more execution options instead of just users running it on our cloud. What did they want, and why did they want to do it that way?
Right. Yeah. So we are currently, we have developed the private load zone feature, and I think that's what you're asking, Nicole, about.
Yeah, in a very leading, subtle way, I thought.
So some customers that came to us said that they are not able to use K6 Cloud because K6 Cloud runs the K6 load generators within our own infrastructure, and therefore they cannot reach endpoints or services that are private, that are not exposed to the internet. And that's been a major blocker for some users in adopting cloud. They have been using K6 locally, because of course locally you can reach the private services, but they couldn't use cloud. So naturally we decided to implement a feature that is called private load zone. So it's a load zone that is deployed within the infrastructure of the customer, and it's only available to that one customer. And K6 Cloud is able to connect to that infrastructure and spin up instances of K6 that then are able to reach all of the private services that the customer allowed it to. Of course, it can be firewalled still, but customer is able to reach those internal services. So that's one reason. The other reason is security. Of course, maybe that's related. Customers don't want to expose private services to the internet, and therefore security is improved if we are able to run within the infrastructure of the customer.
Samuel, could you show us how that works, or how it can be used by users? It's already live, right?
It is already live. It requires, of course, users to actually talk to us and set something up to do it, because it is done in their AWS cloud, and so the process would be for them basically to set up, give us particular permissions basically to start spin up instances in their private cloud. That's something I was thinking to say. So yeah, so the otherwise the how it works on our end, what the changes we have had to do on our end, is that we in the past we only used our own cloud, so we knew we had access to it. Now we need to start passing around, the credentials that we have gotten from the user. And it also means that when we spin up load generator, we need to set up the private keys, etc., for talking from outside of the system. So because they should not have access to the private keys that we use for other instances, etc. So we need to be able to call home and sync up with in a secure way, so that there's a secure communication between this new sort of external cloud that is being accessed. So that's the additional complexity on our end. But if I'm sharing the screen here now, if you can maybe.
Okay, sure.
So
could you maybe zoom in a little bit?
Sure. That better? So this is an example from the app where I have created a test run with support for private load zone, and it's really not much to it. Basically, this is something you probably are familiar with if you have made a K6 test run in the past. You set up a distribution with different load zones. So an interesting thing here is that you can actually mix and match a private load zone. So up here is this custom load zone. This is a testing one we have now. But if you had your own load zone here, it would be something like your company : Amazon : EU, for example. So this is just the internal name that we would agree on for you to use for your load zone. But you can also mix it with existing ones. These are the existing Amazon sort of public load zones that anyone can use in Paris and in the US here. And that's basically that. So if you run this test, it might take a little while before it gets to the point of getting the data, because we will probably not be able to reuse an existing load zone in this case, but have to spin up a new one. So it was pretty quick actually this time. So once we get, so this is just the normal. You can see we actually have this little symbol up here, which means it's a private one. So Dublin, 3% is running this private load zone, and you can see in the tooltip here, it's a private one. But you also get data from public one if you want to. So, and that's basically it from your perspective. The using this is very straightforward once you have the load zone set up with us. Yeah, and then you get the data. This is a very simple test. But.
Wow. And so are there any differences with regards to the metrics? Are they still being aggregated the same from the private ones as with the public ones?
No, there is no difference. It's all operating the same way. It's just that you are now running the agent on your cloud rather than there's no other difference in how it's presented or how it's aggregated or anything. This is why I'm showing that you can mix them here, because they all come in and it all looks the same. Once we receive them, we don't care if it's where it's coming from. So we ingest it and treat them in the same way. So yeah, that's it for the demo. That's all there is to it, actually.
So are there any concerns with this when, like, for example, the load generator, at least for that particular private load zone, is within the infrastructure of the company, right? So it could be like something on premises or something, or is it just AWS cloud only?
This is AWS only at this time. So this is the only provider we support at this time.
However, I think somebody else on the team is Olha Yevtushenko is going to be working on this feature quite soon, right? To also be able to run distributed tests within the on-premise infrastructure.
Right. Yeah. So that's another feature that is related to private load zones. It is distributed execution of K6 open source, which we already have with K6 operator. So you can have a distributed load test without using our own cloud, but that distributed execution couldn't output data to our cloud. So that was the limitation. Some users wanted to use distributed execution within their own infrastructure, but wanted to output metrics to our cloud, because as you said, Nicole, it is quite a hassle to manage all of the data and store results and visualize it and analyze it. And that's the big selling point of K6 Cloud. So that's another feature that is coming up soon, and we hope to release it within some days or weeks. We are currently stress testing it and verifying that it works as expected. But yeah, it already works within our infrastructure. We've been testing it for the last few weeks, and that's hugely important feature to some customers, because when you use private load zone today with K6, we still have access to your test script. So we can view it on the K6 cloud side, but with the distributed execution with K6 operator, we wouldn't get access to any data of the customer except for metrics. And metrics typically don't have any confidential information. So from security perspective, that is going to be a great feature for many of our users.
I guess we would get the metrics, but also the script, right? If it's being fired off from K6 Cloud.
Well, with the K6 operator, no, we wouldn't.
With the private load zones.
Yes, with private load zones.
With the private load zones, we also get the script, because we still needed to actually spin up. So in the private load zone thing, the actual running of the test run happens on the user's infrastructure, but we still you can still run the test, for example, etc. in the cloud. For that, we need to have the script, right? So that's a different thing from the operator that Pawel is talking about, where it's basically a K6 ingest. So it's almost like it is like doing K6 dash out, but you have many more. You can just do this for many more K6s, pretty much.
Yeah.
So how would a customer get started with this? Talk to us, I guess. Talk to support is the first thing. That's support at k6.io. And then that is basically, I think we discussed in a previous meeting that support will be eventually handling it, but at the beginning, probably because this is a very new feature even to us, it will probably be some sort of collaboration with the backend team as well, right?
It's actually set up to not require backend work at all at this point. So CS team, we will help the CS team, of course, if they have questions about it. But it's not required to do any code change or anything for this to work. It just should
Yeah,
work.
I was thinking that they might have some questions about customers who don't know how to set this up in AWS because we need very specific permissions. We have to K6 Cloud has to be able to start instances and end them, and also there also has to be a way for those instances on their private load zone to be able to communicate back to K6 Cloud for the metrics, right? So, okay, so they have to do this configuration and set up their AWS account, and then what?
At that point, once that is set up, well, and they have the subscription that allows them to use it. So there needs to be there is a manual step from CS to allow the user to use it. But after that, then they can just specify the load zone in their script as I showed before, and it will just work.
So once this is set up, will it also come up in Test Builder or just in the script?
That's a
You
good
know how
question.
in Test Builder you have the load zones, and you can normally select which one you want
No.
to. Okay, so it'll be script.
So. No, I think that will not show up in the test builder. You will need to specify that manually at this time.
Okay, well, I guess the workaround for that is to do it in Test Builder with whatever load zone, convert it to the script, and then just change the load zone there to the private load zone. I mean,
Right.
like with the one that you showed, it was like a single line that changed, that just basically identified the private load zone, right?
Yeah,
Exactly.
but I would say that if this doesn't work yet with Test Builder, this will work very soon with Test Builder because, of course, it should work.
Yeah. No, this is really really cool. I think you already mentioned some things, Pau, some reasons why this is so useful, the security part, and also just and the related reason as well that there are many applications that are behind a firewall or are not publicly accessible. So I think, what are the challenges though? Like, why haven't we done this already? Was this piece of work difficult?
Right? It looks so simple. It's
I
just
know,
like this
right?
one line
I
in the
mean,
script.
is Samuel just slacking off here? Like, what's going on?
Yep, that's
That's
it. No, but it's well, it of course it all comes down to priorities and people actually actively asking for this or really pushing for this requirement. We're starting to get customers that are really more and more interested in this kind of of thing. But yeah, it does require a lot of planning actually and thinking to figure out how to do this on the cloud side. So it is more complex than but we have the advantage of having a pretty modular system in the sense that we can apply to that's it that we can actually plug in and use the same you asked the question if there's a difference between the metrics coming in from the private load zone and another load zone, and there is not. So that does make it easy for us to do this kind of expansion because everything's going through the same pipeline and we can plug in different things there. So our design of the backend system helps us here, but nevertheless to figure out how to actually do this and also in a way that is safe for other customers, so that we don't just share, access to instances willy-nilly, but you need to actually track and maintain secure credentials for each of these load zones separately, etc. It takes a lot of planning to figure out how to do this in a good way without being too patchy or hacky as well.
Yeah, so you've alluded to the fact that it's not just the aggregation of the results that is a problem or a concern to be addressed, but also the storage. Are you able to share how big the database is for all K6 Cloud results?
I looked it up
Yeah.
just before the call because I knew, Nicole, that you would ask. I looked up. I was quite surprised by the number because when I looked about 6 weeks ago or 8 weeks ago, the database size was 30 terabytes or 32 terabytes, I believe. And I looked today, and it was only 11. So it's quite a big difference because we do delete data after the retention period ended. So I think by default, most subscription, we store data for 30 days, I think.
By default. Yeah.
By default. But some customers have 1 year, 2 years data retention. So it must have been that one of the bigger data sets had been dropped recently because it expired. But yeah, we range. I remember the time when we had more than 50 terabytes. It goes up and down.
I wonder if it's also like seasonal, what happened, this time 6 months ago or something,
Yeah.
just before Christmas perhaps. And so maybe lots of companies were testing their Christmas sales of e-commerce and that kind of thing.
Yeah,
But
certainly.
wow, 11 terabytes, even 11 is already a lot. Like, that's already the size of my video collection here for editing. So when you think that this is all text, that is a lot.
It's mostly actually numbers. It's integers and floats. So it's a lot of them.
Wow, okay. I also wanted to mention, by the way, Samuel, that when you were showing the instances starting on K6 Cloud, that was one of my first experiences with the K6 before I even applied for a job. This was when I was, doing some spy stuff. No, I was just trying it out because I had never used it before. But I was so impressed. That was faster. That the starting and provisioning an instance was so fast, and it was so impressive that was one of the first things I wanted to know once I joined K6. Like, how is it that we are faster than Amazon? Because when you start an instance on Amazon, it's way slower than that, even if it's a single instance. And I did get the answer that we reuse those load generators. So how does that work? Just for my own curiosity, have you looked and seen if there are any like memory leaks or something? Is there a downside to reusing already existing instances?
So so we are. We are, as I said, we are reusing it if they have not been idle for too long. So we will close down instances if they are, sitting around with no one picking them up. I mean, there are risks, of course, to having if there are issues, and we do need to clean up instances that die for various reasons, and it does not necessarily have to be our fault. It can be something in the network or in the infrastructure, right, that fails. So you need to be careful to not leave leftover zombie instances behind. But overall, we track and have a list of instances that are currently available, and when it has been used to run a test, it will go into a state where it okay, I'm ready to do something else if you want me, and then we And if it doesn't wait for too long in that state, we will reuse it. But yeah, it varies. I mean, if you are running a really big test, it is very likely that you are going to be spinning up at least some new instance, and then yeah, it's going to be taking a bit longer to get all the resources available. And if you're unlucky, I guess you could also end up, even as for a small test run, you end up with that. But most of the time, you can, at least for a small test run, you will be able to get a reused one, and then you can spin up pretty quickly.
I would add that this is a metric that we are tracking quite closely. How long does it take for us to spin up a test for the user? And on average, at the moment, it's about 26 seconds that between you clicking the button to run a test and us receiving the first results for the test. So this is pretty good, but we hope to do better as well. And as you know, Nicole, we care a lot about developer experience, and it's super important that tests start quickly. And we know that we are probably faster than any other SaaS competitor. I don't know, so maybe not. But we still want to be much faster. So we are pulling those instances and keeping them up and running, and maybe that's not economically efficient, but it is definitely good for developer experience.
There are also other things that could be that. I mean, we can't really affect the spin up time of our AWS instance, but we also need to do other processes before your test can start, right? You need to validate your subscription, check that the test is okay, and so on. And these things can be optimized and be done in a way that is. I mean, we're doing it today in a way that is very recoverable from, so to speak, so that if there is an issue in our system, we can retry in a safe way, and you will usually not get stuck, or at least should be very unlikely for you to get stuck at some state. But nevertheless, this does add time to this 26 seconds that Pawel is talking about, so that there are improvements to be done on the backend side there as well.
So, Nicole, a question to you, because you know better than we do. How long does it take for other SaaS players to start up a test?
Having worked for one previously, the standard response was that you should wait at up to 5 minutes. Anything between 1 to 5 minutes is normal. And after that, if you still haven't had your instances start, then contact support. So yeah, 26 seconds, did you say? That is fantastic. I've experienced something that was similarly fast. The problem with that, though, was that particular SaaS provider, they were able to do that because it was shared infrastructure. So that was a huge problem, because you would run a test and you don't know what the other people that are running on the same load generator are doing. You know, that's completely different and not worth the savings and time, in my opinion. But that was the way that SaaS platform, I guess, was able to justify leaving that load generator up and improve. And that was how they were able to improve the startup time. But like this way is way better because it's still private. Nothing else is running except for the script that you are using on that load generator, at least. So it's way better.
Yeah, I mean, it's not uncommon I mean, one of the issues that can happen. I mean, it's also because the user can customize the script as they want, right? So it's one of the things that a very newbie mistake is to not put a sleep or something in the script, and then you are basically running an infinite loop, or you could be running very, very fast, using up all the CPU. It's a useless test, but it would kill any other instances of things running if they were shared on the same machine.
And it's a very common mistake too, to load test your load generator instead of the application accidentally.
Exactly. So yeah, it would be very bad to have them shared. So you couldn't really trust. We be very undeterministic for you to know when your test fails or not, right? In that case.
An interesting aspect of this is I wonder how the perception of performance it changes because of that awesome animation that we have on K6 Cloud that I love so much. It looks like things are really happening and it's a really nice visualization. It's kind of like how the same experience with a progress bar will be perceived as faster, even if it's actually the same.
That's so funny because the perception of tests starting quicker is actually, I think, negatively impacted by this because we run this animation until the end before we start showing results.
Yeah.
So the test probably has started, but the animation is still running.
Yeah, if you saw the demo I did, it actually switches to running status a good while before it switches actually to the first data coming in. So the test is actually starting there. It just hasn't actually produced any results yet. So yeah, we just don't switch until there's actually data available.
Just another example of how humans can be irrational.
Yeah. Well.
But anyway, that we're actually out of time. That was really interesting. I learned a lot about how the K6 Cloud works. So I want to thank both of you for coming. Do you have any parting words about the backend team or the future of this private load zones feature?
No. Well, apart from try it out and talk to us if you want to use it, and if there is any issues, normally blame front end.
I thought you were going to say blame Pawel.
No.
It's always a front end bug. There is nothing
always
on the
a front end bug.
Pawel, anything from you?
Come and join us if you want to work on features like this. Come and work with us, I guess.
Yeah.
Yeah, that's the link over there. Thank you both for coming, and for those who are watching, thank you for sticking around, and have a great weekend, everybody. See you next week.
Bye-bye.